Welcome to the second part of the designing the solar PV cell and to convert into the array. So earlier we have studied that by using the mathematical equation ISH has been designed. Similarly, what we can do, we have the other parameters like reverse saturation current, photocurrent. These are the three parameters that are left. Like we have the saturation current represented by I naught, then photocurrent IPH, and our total output current is given by I with the reverse saturation current IRS. So we are going to define the IRS value. This is the basic equation that we use for the reverse saturation current, that is ISC divided by exponential part minus of 1. So what we have to do, we need the ISC value should be divided by the exponential term. So this is the ISC value that we have used. This is the ISC value, and rest of the part is in the division part, with that is in the exponential. So we have used the exponential unit, and the parameters like q, voc, n, ns and kt has been taken, and n, ns, k into t is in the multiplication with the temperature. So these are the four parameters, n, ns, k and t minus of 1. So we have used this q into voc. We need the q into voc multiplied divided by this value exponential minus of 1, so that the IRS value can be calculated. Similarly, when we are going to calculate the that is the I naught value, again we are going to go for the I naught value. The I naught value can be calculated similarly like this. We need the saturation current. This is the I naught value. Similarly the saturation current I naught can be calculated, and similarly when we are going for the total current, that is the photocurrent IPH value, the IPH value can be calculated into ISC plus KI into T minus or minus 298 into G upon 1 about 1000. That is the irradiation value that we are going to calculate G. So similarly we have used this. The G has been taken. The equation was like this: IPS should be equal to this value. So we have these equation. So this was the equation. Let me increase the size of it, and the size has been increased to 36. So we have this equation: ISC plus KI T minus of 228 into G divided by 1000. So we have taken the G value that should be divided by 1000. So this was the value G into ISC. The ISC has been taken here, plus KI, this is the addition block, KI T minus of 298. The T has been taken, minus of 298 into KI has been given to this, and the IPH value is calculated like this. Similarly, all the parameters have, by using these equations, these four equations, that is the reverse saturation, so and then the saturation, IPH, and the total I is calculated by this equation. Similarly, when we are going to calculate the last value, that is this one value, this IPH, this is a combination of IPH minus of I naught. Similarly, the mathematical equation has been designed by using this equation, and now we are going to check how it is going to work. This if we check up the 25 degree, that is the standard temperature that is taken here, and 1000 the irradiation. So we are going to calculate the IV and PV characteristic for the given system. This is the IV and the PV curve that has been plotted by this. As you can see, this is the IV characteristic and this is the PV characteristic. Similarly, if the temperature is increased, that is 30 degree has been increased, and we have to check the effect of this. So similarly again we can run it for the time period, and we can see this is the plot that has been obtained at 30 degree. And if we say that the irradiation value is 500 and the temperature at that time is 20 degree, because the irradiation is going to affect it. So now we are going to calculate the IV and PV characteristic for the same system. The IV and the PV characteristic for the same system can be seen here. So this is how we are going to calculate this is how the modeling of the PV cell take place, and this is the process. And similarly,